This is review for day 10. This is the last of the long vector problems, being able to process vectors in a real sense, turning points into direction vectors into lines. So let's take a look at this one. In this question, vector 1, 0 is east, 0, 1 is north. And we have this oil tanker. And down here is the vector. Find the position of the Aristeade at 1300. So at 12 o'clock, this is where it was, the origin, 0, 28. At 1300, t is equal to 1. So x is 0 plus 1 times 6. Y is 28 plus 1 times negative 8. So this is just going to be 620. And if I make an arithmetic error, I apologize. We'll try to not do that. So that was 6 and 20, yeah. The velocity vector, if this is the direction vector, it's also the 6, negative 8. This is my velocity. And so if I know that velocity, I should be able to find the magnitude of the velocity to get the speed. And you can probably see this coming. 6 squared plus negative 8 squared is going to be the square root of 100, which is 10. And if it does, have things like time in hours and distance, looks like you're looking at meters. Don't forget meters per hour. Just remember what those units are. Find a Cartesian equation for the path in the form. Okay, and so we look like we've got most of the information we need. The operative word here is Cartesian form. That means there's no t, no parametrics in it. So what you do is you say x is equal to 0 plus 6t, parametric form y equal to 28 minus 8t. We're going to solve both equations for t. So x over 6 equals t, and y minus 28 over negative 8 equals t. Well, since t equals t, then you can say that x over 6 equals y minus 28 all over negative 8. You cross multiply, and you'll get negative 8 x is equal to 6y minus, well, let's see here, 48, 168. You can divide everything by 2, and you'll get negative 4x minus 3y equals 80, negative 84. If you do, everything's negative, we'll just make it 4x plus 3y equal 84. So if I did the arithmetic correctly, that should be the Cartesian form without any t in it. Another ship is stationary with a point, so that the two, this ship is stationary. So xy just equals 18.4, just sitting out there. Show that the two ships will collide and find the time. So we go back to xy equals 0.28 plus t times 6 negative 8. And since they collide, it's going to run into 18.4. That is the position that it's stationary at. So we want to show that the x collision is the same time as the y collision. So 18 equals 0 plus 6t. Looks like t is going to be equal to 3. Okay? Then 4 is equal to 28 plus 3 times negative 8. Well, negative 24 plus 28 is 4. So therefore, collide. So what I did is I found the time for the X to collide with the stationary ship, put the 3 in here, and then I get 28 minus 24 is 4, so they collide. To avoid the collision, the other ship starts to move at 1300 with a velocity vector of 512. So the Aristeade leaves at 1300, and this one leaves at 1300. So they leave at the same time. Show that the position of the Boadicea for t greater than 1 is given by. All right. So this is the direction vector. That's the direction vector. That's where the 512 comes from. Right? That's where the 512 comes from. And you might say, well, I thought this thing was sitting at 18.4. How come it says 13 negative 8? Well, the reason it says 13 negative 8 is that 13 negative 8 is what happens when you start at 18.4 and add 1 second to 512. And when you go 1 second or 1 hour later, what you're realizing is that the time is going to be 1 hour less. And so we're going to multiply this by negative 1 to get this starting point, 13 negative 8. So 18 minus 5 is 13. 4 minus 12 is negative 8. So that's how they get that. So what they're saying here is, here's the way I would have done it. I would have said xy is equal to 18.4 plus t minus 1 times 512. That's what I would have done because it's going an hour later. So what they did is, look at the mathematics, how beautiful this is. You have xy is equal to 18.4 plus t times 512. Looks familiar? T times 512. But then you've got this negative 1 times 5 and negative 1 times 12. So when you put these two together, that's how you get 13 negative 8 plus t times 512. A little weird. When you do your bowling ball lab, you'll probably put the t minus 1 in there. So it says, how far apart are the two ships at 1500? This is going to be at t equal to, if we start at 12, it'll be t equal to 3. And if you want to do this real quick, what you do is you take the first one at the beginning, put a 3 in here, t equal to 3. I'm going to get a point 18 negative 24. This will be 4. So that will be when t is equal to 3 for this first boat. When t is equal to 3 for this second boat, I'm going to get x equal to 13 plus 15. Y is equal to negative 8 plus 36. So this is 28, and this is also 28. Is that right? 28 and 28. Cool. All right. So you have 18, 12, 18, 4 is one position, and 28, 28 is the other one. So if you want to find the distance, you take the square root, 28 minus 18 squared, plus 28 minus 4 squared, which is the square root of 10 squared plus 24 squared. And whatever that distance is how far apart they are. Pretty nasty, but I would say for the test, if you can get everything figured out to this point, that's great.